Good day everyone. Today we are going to learn about integer from class 7 chapter 1. So under that we are going to learn about properties of addition and subtraction of integers. So before that we have to know certain basics, that is number line. This is a number line 1, 2, 3, 4. And this is -1, -2, -3, and it goes on. This is how we will represent integer, and these digits are called as integers. I hope this is clear. So now let's dive into the topic. So the first the first property we are going to see is closure under addition. So closure under addition, let's take example as whole numbers. So we know whole numbers hold this property. Let's take an example and prove that. Let's take 17 and 24. These two are whole numbers, and if we add 17 plus 24, we are getting 41. This is a integer. Sorry, this is an whole number. This is a whole number. These both are whole numbers. So from this we can say closure is true for whole numbers. So same way we will prove for an integer. Let's take few examples. Let's take here statements. And here observation. So first example, that is 17 plus 23. This is equals to 40. Here this is an integer. This is an integer. And this is an integer. So from here we can write the observation as the answer is integer. Now we'll take another two numbers. -10 plus -3. The answer is -13. So here if you see, this is an integer, this is an integer, and this is an integer. So here we can say the observation that the answer is also an integer. Now again we will take another example. Let's say -20 plus 20. This is integer, this is integer, and the answer is, of course, it is an integer. So from this we can say integers are closed under addition. So from this we can write the result as for any two integer a and b, a plus b is an integer. So this is true for addition. Now we will see for subtraction. So closure property and subtraction. So in the same way we did for addition, we will do for subtraction. Here we will write the statement, and here we will write the observation. So let's take 7 minus 8. This is an integer, this is an integer, and of course the answer is 1, which is also an integer. So the observation we can write here is integer. Now we'll take another example. 17 subtraction of -7, which is 17 plus 7, which is 24. So this is an integer. You can see here 17 is an integer, -7 is an integer, and the answer we are getting 24 is also an integer. And let's take another example. -29 plus 29, which is 0. And the answer we are getting here is also an integer. 29, 29, and 0. 0 is also an integer, and 29 is also an integer. -29 is also an integer. So the answer we are getting here is an integer. So from these all three examples, we can say if A and B are two integers, then A subtraction of B is also an integer. So first we will write integers are closed under subtraction, and the result can write if A and B are two integers, then A minus B is also an integer. So now we will jump on to the next property, that is commutative property. So we know that 3 plus 5 equals to 5 plus 3, which is equals to 8. In whole numbers, we know that 3 plus 5 is equals to 5 plus 3, which is equals to 8. Let's see whether this is true for the integers. So let's see first for addition. For addition, if we see, first one is we will write the statement. And we will write the observation here. So it will be easy for us. So first, if we see -8 plus of -9, which we will get as -70. So now again we will do the other part. This is LHS. Now we will do the RHS. So -9 plus of -8, which is also -70. So from this we can write the observation that if we perform commutative property here, the answer we are getting is same. So this proves that commutative property is true for addition for integers. We will write another example. So -1 plus of -2, which is -3. Again -2 plus of -1, which is -3. So this here, this is integer, and this is also an integer. This is integer, this is integer, which is this is also an integer, and these both are equal. That is, RHS is equals to LHS. This proves that, and both are equal. This proves that commutative property is true for addition and for integers. So result, we can write that addition is commutative for integers. Now we will see for subtraction. Let's take 5 example, same way statement. Here observation. So let's take -5, negative of -3, LHS side, which is equals to -5 plus 3, which is -2. Let's now write the right hand side, which is -3, negative of -5, which is -3 plus 5, which is +2. From this, we can say these two are not equal, which means this property is not true for subtraction. We'll take another example. That is, let's say -2 plus, -2 of -10, which is, this is LHS side, which is equals to -12. Then again 10, negative of -2, which is +12. So since these both are not equal, this means this property is not true for subtraction. So we can write the result as subtraction is not commutative for integers. Subtraction is not commutative for integers. Yeah. Now we will see another property, that is associative property. So let's check for addition.